Hey guys, welcome back. So we're looking at 1.4 today. 1.4 is pull a rabbit out of the hat? Pulling a rabbit out of the hat. Sorry, can't remember the name of it. All right, so let's go ahead and jump right on in. Okay, so for this first part, we're taking and looking at using the product rule or the quotient rule to simplify. Leave all answers in exponential form with only positive exponents. Note the only positive exponents is going to be important. Okay, so let me make this bigger. Oops, not that, this. Okay, so the first one I'm doing is number 1. We have 3 to the 6th power times 3 to the 5th power. When our base numbers are the same, rather than having to find what 3 to the 6th is and what 3 to the 5th is and then multiply them, when the base numbers are the same, so remember these are both base numbers, we add the exponents. So a to the x times a to the y equals a to the x plus y. So what we're going to take and do is we're going to add these exponents. So we're going to have 3 to the 6 plus 5. Well, 6 plus 5 is 11. So it's 3 to the 11th power. That's your answer. That's all you have to do. You do not have to take and find what 3 to the 11th power is. That'd be a very large number. You do not have to find what that is. You only have to take and put it in exponential form. All right, the next one we're looking at is a little bit different. So we have number 9. We have 9 to the 8th power over 9. Now, this second 9, remember, any number that we have always has an exponent of 1 if it doesn't have another exponent given. So the rule for this is when the base numbers are the same, so our rule, we subtract the exponents. So we're going to have 9 to the 8 minus 1. 9 to the 8 minus 1. Well, 8 minus 1 is 7. So it's 9 to the 7th. Once again, you do not under any circumstances have to find what 9 to the 7th power is, okay? All right, the last one. Now, this one, once again, we're going to use the subtraction that we have over here. So we're going to have 3 to the 5 minus 8. So 3 to the, 5 minus 8 is what? Negative 3. Now, in the directions, it specifically said to only have positive exponents. This is not positive. So in order to have a positive exponent, the rule is if we have a negative exponent, it's the same thing as having 1 over that value to that exponent without the negative anymore. So this is going to become 1 over 3 to the now positive third. Because 3 to the negative third is 1/27th. So it's 1 over 27. And so that's how we get that, because 3 to the third power would just be 27. So 3 to the negative third power is 1 over 27. So that can kind of help you figure out how this works here. Okay? All right, so those are your exponent rules. If you have the base numbers are the same and they're being multiplied together, you add the exponents. If you are dividing, you subtract the exponents. And you always want to have a positive exponent. All right, the next section right here is about inverse functions. So given the functions f of x equals the square root of x minus 1 and g of x equals x squared plus 7, we're going to calculate these as different things. Now, I'm only going to do a few of these. I'm only going to do a couple with you, and then you'll be figuring out the rest. But hopefully it'll help prepare you. Okay, so I'm doing part A with you guys. So we have f of 16. So that means we're taking our f of x function. So f of 16 equals the square root. Remember, whatever number is in the parentheses there is what goes in for the variable over here. So it's going to be the square root of 16 minus 1. Well, the square root of 16 is 4, because 4 times 4 gives us 16. And then minus 1. 4 minus 1 is 3. Now we're going to do the g of 3. So now we use the g of x function. So we're going to have g of 3 equals 3 squared plus 7. So, like I said before, whatever number is in the parentheses, it's going to go in place of the variable. Now, 3 squared is 9, because 3 times 3 is 9, plus 7. 9 plus 7 is 16. Now, what do you guys notice? In this case, the ordered pair is 16, 3. Over here, the ordered pair is 3, 16. They are flipped around, which means that these two functions would be inverses, sort of. They're on the way to being inverses of each other. So I also just did B and C for you because it wanted you to take and write them as ordered pairs. So make note of that. And I kind of did D for you as well. So you guys will take and finish up D, E, F, G, and H. So those will be for you guys to take and work through, okay? All right. So the next part of this is matching. So match the function in the first column with its inverse in the second column. So we have all these different functions, and we want to find their inverses. So for this first one, we have f of x equals 3x plus 5. So what we need to take and do is find one that does the opposite of that. So here we're adding 5 and multiplying by 3. So we want to find one that subtracts 5 and divides by 3. So if we look over here, ding, 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 subtracts 5, divides by 3. We also have this one. Now, these are two different equations. They also go with two different equations on the other side. So we always start, basically we're unsolving it. So what we'd do to get x by itself here, we'd subtract 5. It'd go over to this side. And then we divide by 3. So everything would be divided by 3. So that means 16. Sorry, you guys can't really read that. Bless me. 16 is C. So that means this one is now gone. Now, 17, f of x equals x to the 5th power. Now, when we're taking something to the 5th power, to undo that, we need to take the 5th root. So which one of these has the 5th root? That would be G. All right, the next one I'm going to do with you guys is number 20. We have 5 to the power of x. Now, anytime we have the variable in the exponent, the inverse of that is the log function. So we look for the one that has the 5. So this is log base 5 of x. Remember, 5 is your base number there. X is your exponent. So these two connect exactly. So hopefully that'll help you guys get some ideas for how to take and find the remainder of these. So we've done C, G, and A. So you just have to figure out what B, D, E, and F go to. But remember each of the things that I talked about within those. If you've got a base number to an exponent, you're going to do the log of that. If you've got a variable to a root, you're going to take that root. And when you have linear equations, you have to take and undo the equation. So solve for the variable. Okay? All right. I'm going to do the remainder of this in a second video. The keyword for this lesson is exponent. The keyword for the second video will also be exponent. There's only one keyword for the lesson. But your keyword is exponent. Make sure you watch both videos. If you have any questions, feel free to ask. Bye, guys.